Sometimes we talk about doing a qualitative analysis as opposed to a quantitative analysis. So a qualitative analysis consists of figuring out the general form of solutions without having a formula for them. So this means finding equilibrium solutions, isoclines, places where the solution is increasing or decreasing, and inflection points, that kind of thing. And so this is basically using all the stuff you learned in your first quarter of calculus about how to interpret the meaning of y prime equals and then some expression. So from the derivative, you know that when y prime is positive, the function is going to be increasing and so on and so forth. So let's do a qualitative analysis. So for example, we will look at, say we go back to that logistic equation. Now we'll see how to solve the logistic equation soon enough, but even without being able to solve it, we can look at something like this, and we can actually graph what the solutions are going to look like. So let's begin by looking for equilibrium solutions. Well, equilibrium solutions, these are going to be where P is constant, so where P prime is equal to 0. So that means we're just going to be looking at where Kp m minus P is equal to 0, because that's our formula for P prime. So we look at this and say, okay, well, we've got basically a product of two functions here, and one of these has to be equal to 0. Okay, so then that tells us that P equals 0 is an equilibrium solution, and so is P equals m. So we can put that data to some good use here and say, all right, we know that, let's see, so P equals m, so that's going to be an equilibrium solution, and then also P equals 0, that's going to be an equilibrium solution. Okay, and then we can maybe go a step further and look at the signs for what's going on here. So let's see. So suppose we look at the region between these two lines. So this is where we've got P is between 0 and m. And then we'll also have the region up above, and that'll be where P is greater than m, and the region down below, and so this will be where P is less than 0. Okay, and so in each of these, we can consider the sign of the terms involved. So actually, let me just move everything down a skosh so I have more room. There we go. And so now if I look at my expression for P prime, so this was Kp m minus P, then let's see what we have in each of these different scenarios. So if we're in the one where P is bigger than m, the first one, then P is positive, and P being bigger than m means that m minus P is going to be negative. So we have a positive times a negative. So the net sign right here is going to be negative. So I'll put a little minus sign over there to indicate that it's decreasing. Actually, here we'll put a little bar like that on the vertical axis. Okay, so now let's look at the region between the two. In this case, P is still positive, but now P is less than m, so m minus P is also positive. So that means it's going to be net of positive, so it'll be going upward. And then if we look where P is negative, then we will we'll see, okay, so we've got a minus sign here, and then a positive sign here, because P is still less than m. So the net is negative, so it'll be decreasing. Okay, so that tells us that the function is going to be increasing in the middle, decreasing above and below. What else can we determine by looking at this thing? Well, we can look for inflection points. So for inflection points, let's see, that'll be where the derivative changes from being an increasing derivative to a decreasing derivative. So we need to look at the second derivative. So we apply product rule and we see we've got km minus p minus kp for our second derivative. And so that's equal to, let's see, we've got km minus 2kp. And so k is a positive constant. So this is going to be equal to 0 if and only if we have m equal to 2p, or p equals m over 2. So we go back to the figure here and we say, okay, so we have inflection points at along this line right here, m over 2. So that tells us that if we are below this line, we have the derivative is increasing as we come up to m over 2, and then so we're getting steeper and steeper, and then after we get up to m over 2, it goes back to flattening off again, like so. Okay, and so putting all this information together, and then all of this is going to be this repeated at different points further down. Wow, this is not my best sketch, but okay, something like that. And so putting this all together, then we find that the solution curves are going to be things that increase and then keep increasing, but at a slower and slower rate. And then things that start above are going to decrease exponentially, and things that start below are just going to take off downward, decreasing exponentially, like that. Okay, that's a reasonably good plot of what the solution curves look like for this logistic model.